So far, throughout every single demo that we ever did, we printed something to the console. Now, what we printed is text, and the way that we got text to be created out of single characters is by putting double quotes and then putting the actual text in between. Now, in certain cases, we had text transformed, like, for example, the curlies here, they were transformed before the text was output. But the overall idea is that we had a bunch of characters and we put them together to make a string. So, for example, in the Rust language, you can do something like let s equals hello there! Exclamation mark. So S effectively becomes a string. A string is simply a collection of characters. In fact, it's a vector of characters. However, strings are not quite so simple when it comes to Rust because there are two different string types and we have to talk about both of them. So the actual type, if I were to do a type declaration here for this particular string, would be maybe a bit surprising to you. So the type is actually a reference to a static str. So what is it? What's going on here? Well, AmpStr is one of the two types that we need to talk about. AmpStr is essentially something called a string slice. So a string slice is kind of a view into a string, if you will, kind of similar to the way that we had slices into arrays and vectors. This would be a slice into a string. So what is the static bit? Well, the static bit basically tells us that the entire string, hello there, is going to be included right inside our program. When we reference it, we reference a particular location in our program. So it gets glued into the actual code that we compile. Whereas obviously if you make a string at runtime, that's not how it works. It just allocates memory and then you operate on this memory. So this particular string slice is statically allocated, and string slices are not particularly flexible. You cannot, for example, reassign a string slice. Something like this would not work. And similarly, what you cannot do is you cannot manipulate the individual characters. So you cannot, for example, say let h equals s at 0 to get the first character. This is not how it works in Rust generally. So in both this type, the AmpStr, as well as the string type, which we'll see in a moment, what you're essentially getting is you're getting a valid sequence of UTF-8 characters. So the idea of kind of indexing into it would be difficult, even if you could do it, because you would be indexing the bytes, the Unicode kind of code points, which might not be what you want. However, it is possible to take this string and it is possible to actually get the characters as a sequence. So for example, I can say something like for C in s.characters. So chars is a special function which actually gives you a sequence of characters, and you can do something with them. Like for example, you can print line those characters to the console. So let's see what happens if we do this. Well, we essentially get hello there exclamation mark printed as the individual characters. Since this is a sequence, I can also call things on it. Like for example, I can reverse this entire thing and run this, and I will get the letters in reverse order like so. And of course, once I'm done s.chars, I then get effectively an array that I can manipulate, and that's where I can perform the various changes, but it would be nothing to do with the original string. Now also, there is a kind of safe way of getting a particular character. Like let's say I really want the first character of a string. Now remember that generally the when you try to access something from a sequence like this, you get an option. You either get a sum or a none. So if I really want the first character, I would have to write something like this: if let sum of first character equals s.chars, and then take the nth character, so nth with the value of 0. So I want the initial character of the string. If there is one, then I can print it out. So I can say first letter is, and then take this first char. And this is possible thanks to the magic of if let. So let's run this, and you see the first character is in fact H. So you can get the individual letters. However, for purposes of flexibility, there is entirely another different kind of construct, and this construct is called a string. That's with a capital S and without the abbreviation. Now, a string is a heap allocated construct, and it's also guaranteed to be valid UTF-8 sequence. So let's take a look at what that is used for. Now, remember, the str is a fairly inflexible object. You have it, but there isn't much that you can do with it. When you want to grow a string, like you would grow a vector, for example, that's where you would use a string. So, for example, let's suppose I want to build a string out of every single letter in the alphabet, comma delimited. What I would do is I would say something like let mutable letters equals string new. So effectively I'm making a new object of type string with a capital S here. And then let's cycle through all the letters using a while loop. So I'll start with the letter A, which is going to be just the letter A, but I'm going to use a U8 type for it. And then what I'm going to say is while A is less than or equal to the letter Z as once again a U8 type, what we're going to do is we're going to add things to letters. And remember, letters is, well, it's effectively a vector, so it has that push function. So we can say letters.push, and here I will take A, I would cast it back to a character because it's now a U8, A as char. And then what I'm going to do is put a comma in there. So I'll say letters.push. Now notice something interesting. If I want to append a string, like for example a comma, it's not the same as appending, let's say, a character. So for that there is a special function called push_str, and this function takes a string slice and it accepts that as the kind of what you're effectively adding. And then I'm going to increase the count of variables, so I'll increase A by 1. And maybe there is a more effective way of cycling through all the letters, but we're going to do it like this, and then I'm going to print line all the letters. There we go. Control F5. Let's see what we get. Oh, unresolved. Yeah, sorry, forgot a letter here. Let's go. All right, so we get a sequence of every single letter from A to Z, and we print that out. So effectively, if you want to have a string which you can sort of modify, then it is the choice, the data type of choice is this string construct. That's how you do it. Okay, so you're going to see APIs which take a capital string. You're going to see APIs which take string slices. It does take a bit of time getting used to. Now, when it comes to conversion between str or ampstr, to be more precise, and string, those are fairly straightforward. So for example, if you want to make an ampstr from a string, like from letters, for example, then you simply write something like let u of type ampstr equals amp letters. That's all you need to do it. This is actually possible through the magic of so-called deref conversions. And one thing to point out is that there are situations where this kind of conversion from a string to an str will not work, but those are fairly advanced, so we're not going to talk about them. There is also the business of concatenation. Concatenation is basically adding a string to another string, and of course you can have lots of combinations here. A string, if you want to concatenate a string and an str, that will work just fine. So for example, if I want to say let z equals, for example, our original string, which is letters plus ABC, then I'm going to have a sequence of every single letter and then the ABC added to the end. However, if I want to concatenate two strings like letters and letters, for example, then all I have to do is cause a deref conversion on the second letter, which would cause it to become an str, and then everything is once again fine. So this is how you typically concatenate, sort of join strings together. It's also possible to, if you want to take, let's say you want to make a string from an str. So let mutable ABC equals, how would you typically make a string from an str? Well, there are two different ways. One is you just say string from, and you say hello world, and that's it. That's how you make a string from a string slice. Alternatively, what you can do is you can take a string slice, hello world, and then you can call a function to_string on it, which once again gives you a string. Now you can manipulate the string. So for example, I can remove the first character by saying abc.remove at 0. I can also add something to the end. I can add an additional string. I can say abc.push_str, add a couple of exclamation marks. And here what I can do, I forgot the double quotes in here. Here what I can do is I can actually print line the string, but I can also replace the LO. Remember, we destroyed the H. I can replace LO with goodbye, for example. So I can say abc.replace LO by goodbye. And as I run this, you'll see that, well, as soon as we get the whole thing to work, because I think we forgot the closing bracket somewhere. Yeah, we forgot a bracket in here. So let's execute this, and you'll see that I have goodbye world with those 3 exclamation marks that I've appended.